Okay, Peter. So we saw with classification that we can basically determine who is going to churn if we know the target. That being said, a lot of data doesn't always necessarily have a target. What if our data set isn't as good? What can we do with our algorithms?
Yeah, so what we did was classification, so it was supervised, so we already know the answer for a certain part of our data, so we can just use it to train a model to cover this. Sometimes you do not have the results in the data set, sometimes you do not know the answers, and then there are other methods you can use. In our case, we provided a clustering algorithm to do unsupervised learning. So what we do in the demo now is we're using the same data set, but we extracted the target column. So that we deleted it for this in this data set, and we're using the exact same data set, but we are not giving the target to the algorithm. So the algorithm does not know where to search from.
Right.
The algorithm just cluster these data which is in there into different clusters, into different segments, which then have something in common. And we will then test if this has something to do with our chosen target in this thing here. It is churn. So we have this demo here. We have also the different features here. We cannot do feature selection with non-targeted data. So if you don't have a target there, we cannot choose the features for this target. So this will be not present in a clustering environment. However, we will have data experts, so they can give us input. So what is important and what not, or what they think it's important, and we can always add more.
So when you say a data expert, do you mean a data scientist, or do you mean someone who's more an expert on this particular data set?
No data scientist, but a domain expert. Okay. So in this case, it could be a salesperson or a controller who has knowledge about, okay, these people leave, these people stay, and so on. So, and they can tell us, okay, normally it's about tenure, how long the customer stayed, or maybe it's about the contract length. So we will put this there, and we have other features, so just put it there. Okay. But these two columns here, the rank and the confidence, we would not have for clustering. So we just have to choose one. We just have to choose some of these, and we can also choose all. And then we will run clustering. And clustering will just look at similarities in these data sets. So for all these features, all the combinations are tested, but as we have no target, it's just tested what is similar, where is everything somehow in a similar category. Okay. And we will get then we will get back a number or a category. So for each cluster. Mm-hmm. So in this case, in this report, we already know that we will get 3 clusters. But you will just get a number. So this data set is in cluster 1, this is in cluster 2, cluster 3, cluster 4. It doesn't matter. We can also name it A, B, C. And we will get like this cluster. So it's in segment 1, 2, 3. It will be the same so the classification will give us back churn yes, churn no. So one or yes and no. And the clustering will give us back 1, 2, 3, 4. However, how many clusters there are. And then we can go through this and see it in a cluster.
It looks like we have some results now.
Yes. So what we see now here is it's not all customers because we have 7,000, but it's a sample of these customers and how they are distributed over the clusters. So it's a visualization. So we have now a cluster about 17 dimensions. So it would be a 17-dimensional clustering. So it's hard to display. So but we found some visualization methods which put this into a 2D format. So what we are seeing now is that this group is completely separated from the other group. These are somehow overlapping. We also have some outliers. But what you can see is, in the end, that we have 3 different clusters here. And these would be our groups of our customers. So now we have 3 groups, and now we have to find out what do they have in common. What makes it easier for us now is that we already know the target. We can just look at this and compare it to the targets. And what we see here is that in this case for cluster 2, churn ratio is 14-15%. For cluster 3, it's 7%. So if you are a customer in these 2 clusters, then you would like to stay with a contract. In this year, we have a churn ratio of 39%. So this means more or less, so it's more like than the average. So in this case, we do not know. Maybe they will leave, maybe they will stay. We don't know. So if the customers in this cluster, we have to check. So we have to see, is this do we think that he will leave or not? Or if we don't see this in the data, we just contact him and say, okay, what can we do for you? Like we had with the classification results. So what we see is, even without knowing the target, this algorithm gives us something back which we can work with. So like these 2 things would be churn no, and this would be churn yes, and then we can start working with that again. And we also can see this in the report we had from the classification also. So what we see now here is that we have like another assisted churn here. So it's the same thing. We get the result from clustering instead of classification now. And we marked everything as churn no, which is in cluster 2 and 3, and everything is churn yes, which is in cluster 1. And then we get this number. It's slightly different from the classification part. And we do the same thing. And in the end, we have this 12 million, and we have this churn at 20%. So we also have now a more transparent, more accurate calculation of this churn, even without knowing, or the algorithm not knowing the real target.
Can you go back to that?
Yes, for sure.
Can you talk a little bit about our accuracy values here? What does that mean?
Yeah. So in our case, we know the answers. Yes. So we just compare these values to the real values. So it's also something to check, to double check if classification gives good results or the other way around. Okay. So and also what we can also do is we can use these results now for classification as a classification input. Because before we didn't have the targets. Now we have some clustering, some targets, and we can use them into classification, train a model, and to reuse the model. Okay. And here it's also like if we do not have the target, and if it's not so easy to get to the targets, we can analyze the data now. So we can look at all the customers which are on cluster 2, which are on cluster 1 and cluster 3, and normally we get something. Okay, there are. Almost all of them are in month-to-month contracts. Almost all of them have a high tenure. Almost all of them have a low total charge or something like this. So we have to analyze something. So there's some additional work here in the end. But it also gives us a good impression of how we can group our customers. And if we're thinking not about customer churn, but about something else like key customers or something, or like groups of products. So then this algorithm will group the customers or the products into groups that have something in common. Mm-hmm. That's the important part. They have something in common. If this is like in this case, the churn, or if it's just like these products look very similar, they are sold similar, they have similar prices or something like this. That depends on the data, but we get similarity here, and that's the point, not only in one feature and not only in one dimension like price or total charges, but in as many as I give as an input. So if I give 10 features as an input, we will have groups there over all these 10 feature inputs.
So if we don't know a lot about the data and we don't have target, we can use this clustering to group different products or customers. We could then create a report that shows us what they have in common, and from there make some choices.
Yeah, exactly. So we also have prepared something like this. This one, so there's there we have the cluster again, and then you can go here, cluster 1, cluster 2, cluster 3, and then you see, okay, DSL is used by 110, 62, 4. So we mark everything which is very low or very high. So you can see, okay, this is what they have in common or not in common, and then you can build your own tag on this cluster, because that it is. So we tagged 2 and 3 as churn no and 1 as churn yes. So or we labeled it, and this is what you have to do in the end. And then, as I said, you can use this as an input for classification and go on with that what we already did.
That's a fantastic way to use data that maybe would otherwise feel a little and not useless, but a little directionless.
Yes.
Yeah.
So really to get to know more of the data and also to get more out of the data, because if you know that you can group it in certain ways, then maybe you can think of additional KPIs or measures or use cases to use the data in that way. And this is a perfect way to do this. Throw everything in and get some information out.
Fantastic.